Hey guys, today we are practicing with mole ratios. So as always, I'm going to do a couple of examples with you to make sure that we are all on the same page and we know how to do these problems. So this is a Google Slides assignment. You guys are going to be doing some dragging and dropping, some calculating, some typing in, etc. So the first slide is just the title and then directions on how to complete. And then there's a slide that you have to complete on 3. I'll do a couple of those with you here in just a minute. 4 is an example slide. If you go to the slideshow and then click through it, it will show you an example and tell you how to do everything. So there's this little like play button up in the top. So that's just an example. You don't have to do anything with that. And then there are some calculations on 5, 6, 7, and 8. I will do slide 5 with you guys, so you'll only have to do 6 problems total. And again, they should go pretty quickly because you don't actually have to type a lot out. You're just solving and doing the calculations, okay? So on slide 3, this is asking for just the mole ratios. So these numbers right here are available to drag and drop. So if you drag them, they duplicate. So you just have to drag and drop from the actual chemical equation. So we've got 2 aluminum plus 3 copper chloride will yield 2 aluminum chloride plus 3 copper. So this is already balanced for us. And here we just have to do our ratios. So this first one wants moles of aluminum to moles of copper chloride. So all we have to do here is drag the coefficient in front of either the element or the compound to the correct one. So moles of aluminum, we have that coefficient of 2 in front of the aluminum, so we just have to click on it and drag it to the spot. And then moles of copper chloride, the copper chloride is right here. There's 3 moles, so I'm just going to grab that coefficient and drag it. Okay, so this is just asking you to tell me the ratios. Again, you just have to find the coefficient in front of the compound and drag it. So like copper chloride is always going to be this 3 because the coefficient is 3, so we're going to drag it. And then aluminum chloride is 2, got that coefficient of 2, we're going to drag it. So that means for every 3 moles of copper chloride, there's going to be 2 moles of aluminum chloride in this particular equation. Okay, so that's all you have to do for that one. You guys should be able to do the last 3 pretty easily. Now I'm going to show you guys how to do the calculation slide. So I'm going to do 1 and 2 for you, then you guys will do 3 through 8. So on these slides, on the top, we're going to have our balanced equation. So it's right here. So we've got P4, 1P4 plus 3O2 will yield 2P2O3, and this is what we're going to help us use to set up our equation. So we're going to drag and drop, and we're going to solve. Okay, so question 1 says, how many moles of O2 will react with 3.4 moles of P4? So we've got our units here, and we have what we're starting with, so we can actually use this. We can drag and drop to our first part of our T-chart here. So I'm just going to drag and drop that there because we always start with what we know. We know we have 3.4 moles of P4. Now let's go ahead and let's set up our conversion factor, which is just going to be our mole ratio. So I know I want to end up with moles of O2, and I want to eliminate my moles of P4. So my moles of P4 have to go on the bottom. So I'm going to drag and drop. I know my moles of P4 have to go on the bottom. And I want to end with my moles of O2, so my moles of O2 have to go on the top. Okay, again, because the P4 is in the bottom, that means that that is going to eliminate because that's just a fraction. So if you have a P4 on top and a P4 on the bottom, those go away, and then my O2 is left. Okay, don't have to worry about P2O3 in this problem because it's not asking about P2O3. So now let's do our ratio. So we have to go to our finished or our balanced equation to help us find our ratio. So I'm going to grab the coefficient from our O2, which is 3. So I'm going to go ahead and grab him, put him right there. And then P4 is 1, so I'm going to take the 1. So what this means is that in this particular reaction, for every 1 mole of P4, there will be 3 moles of O2. Okay, that's what that means. So now we just have to solve, and we're going to type our answer here into this box, and we'll have to type that in. So let me go ahead and I'll pull up my calculator, my Desmos calculator, which I have linked for you guys today. So I'm going to do 3.4 times 3, because remember these are fractions, so I multiply across the top, multiply across the bottom, and then divide if necessary. So 3.4 times 3 is 10.2, and we would divide by 1, but whatever, dividing by 1 just gives us the answer, so it's going to be 10.2. So our answer here is 10.2 moles of O2. Okay, so that is our answer. So 3.4 times 3 divided by 1 gives us 10.2. And again, this would be moles of O2 because we've eliminated our moles of P4 and we're left with our moles of O2. Remember, in chemistry, we don't want any naked numbers because that is not good. So then let's do number 2. How many moles of P4 are needed to produce 2.9 moles of P2O3? Same thing, I'm going to drag and drop my known to get us started over here on the left-hand side. And now I'm going to set up my ratio. So I want to get rid of my P2O3. So my moles of P2O3 need to go on the bottom. And I want to be left with my moles of P4. So my moles of P4 need to go on the top. Okay, and these boxes can be a little bit tricky. You can drag them. Once you see the little 4 arrows on it, that's when you can click and drag them. Okay, so now I have to set up my conversion factor, which is my mole ratio. So again, we're just taking the coefficients in front of the compound. So for every 1 mole of P4, there are 2 moles of P2O3. Okay, so now we do have something, a value on the bottom. So to solve this, we're going to do 2.9 times 1 divided by 2, okay, which will wind up being just 2.9 divided by 2. So let's go ahead and do that. And again, it's 2.9, which will give us 1.45. And again, moles of P4. And again, we want to keep our, we've got a capital. We want to keep our units, so we're sure we know we have them right. Again, our P2O3 are canceling out, which is leaving us with our P4. And so this means in this equation, for every 2.9 moles of P2O3 there are, we would have 1.45 moles of P4. And that makes sense because since it's a 1-to-2 ratio, there will always be more P2O3 than there is of the P4. Okay? Same thing on this side. So like from here, we went from P4 to O2. There's more O2 than there is P4 because it's a 1-to-3 ratio. So it makes sense that we wound up with more moles of the O2 than what we started with the P4. Okay, so use these examples to help you answer the rest of the questions. Again, drag and dropping. These calculations don't take as long because a lot of it's already done for you digitally. You just really are having to make sure you set it up correctly and then typing it into the calculator correctly. If you have any questions, let me know, and if not, I will see you guys in our next video.